Morning, grade 7. Today we're going to continue working with triangles. So I'm going to start with a little bit of a review from the videos that you had watched yesterday. So when you watch those videos online, sometimes I choose to have you watch those instead of listen to my own video because they just have a little bit of better technology to cover all the different ideas. I also like that you can right away try some of the questions and problems and get immediate feedback on how you're doing. So that's why sometimes we're going to be using those still. But for today, I just want to quickly review classifying triangles. Remember, the word classifying is another word for naming triangles. What I want to highlight is a couple things. The first thing I want to highlight is there's only one kind of equilateral triangle. If our triangle is equilateral, it has to also be acute, okay? Because as soon as we have an obtuse angle, we cannot have three obtuse angles to make an equilateral triangle. You won't end up with a triangle, or you'll end up with a triangle that has an opening in it, which does not actually count as a proper shape. So there's only one kind of equilateral triangle, and it is acute. Then we have three different kinds of isosceles triangles. I don't know about you, but I have a very hard time spelling the word isosceles. So we have the acute, right, and obtuse. So remember, the definition of isosceles is that there are two sides that are the same, okay? Also remember, these little notches here tell you that they are equal. Then we have the scalene triangle, and the scalene triangle simply means none of the sides are the same. So when you start to classify triangles or name triangles, make sure that you're using both types of words. So what I mean by that is words that talk about the angles that are happening, the angles like obtuse, acute, and right. And then also use at least one word, obviously, that shows you the side length of the triangle. That gives you the most information about triangles. So there we have our 7 different types of triangles, just as review. Now today we're going to talk about congruent triangles. The word congruent means equal, or exactly the same. Here we have the symbol to show us that angle ABC and DEF are congruent to each other. So when we talk about triangles that are congruent, we mean they are exactly the same. Every single side is the same, and every single angle within them is the same. So it doesn't mean they're equilateral triangles, but it means that every angle has a matching angle. So for example, angle C perfectly matches F, angle E matches B, and so on. Once again, we see these notches helping us out. So if you take a look over here, we have 2 notches, which matches up with the 2 notches over here. So we know that those 2 sides are congruent or equal. So here we have this diagram that has showed us that all 3 angles and all 3 sides for both triangles are congruent, so they are exactly the same. In a lesson, I think it's going to happen on Friday, we're going to talk about similar triangles. They're not the same as congruent, so I really want you to just remember congruent means exactly the same. Same angles, same sides. Now, when we're working with congruent triangles, there are 3 different ways to figure out if a triangle is congruent. So this one up here, back for a second, it was quite obvious they were congruent, if you can see past my scribbles, because it showed us all 3 angles are the same and all 3 sides are the same. It gave us all the information. But we can actually determine if 2 triangles are congruent with less information. So one way we can do that is talking about the 3 sides. So what we call side, 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 or the triple S. So take a look at these triangles. Notice that we have AB and line PQ are congruent. They have matching symbols. Then QR and BC are congruent, and then PR and AC are congruent. It doesn't matter that my triangle PQR is tipped or tilted. It's still perfectly congruent with triangle ABC because all 3 sides are the same. So you can even try that on a piece of paper. If you draw a triangle and measure the sides, maybe the sides are 5, 4, and 3 centimeters, and you want to draw another triangle with the same side lengths, you will notice that your angles will be exactly the same. So in this case, angle A and angle P match each other. B and Q match each other and C and R match each other. So that tells me that my two triangles here are perfectly congruent. The angles are the same and the sides are the same. Now the way I knew that angle P and angle A equaled each other was I looked at what lines they're in between. So I noticed that P was in between the one short dash and then the three dashes. And then A is also between three dashes and one short dash. That's how I knew that those angles were congruent. So when you're trying to decide if an angle is congruent, if all three sides are the same, automatically your angles have to be the same because you can't change the length of your triangle. So that's side, side, side. Then we have side, angle, side. So again, these are congruent. Just picture that angle X or triangle XYZ is tilted. But what I want you to notice is that we're given only three pieces of information again. So we're told these angles match, and then we're told these two sides match. Now, if you think about it logically, why would that help me know that these triangles are perfectly congruent? Well, again, feel free to try this on your math journal. If you were to draw a triangle with a line and then with a short line, and you gave it an angle, perhaps you measured it and it was, let's say, 60 degrees. If you were going to draw that again, obviously I can't do it perfectly on my iPad, and you were to make sure it was 60 degrees and the exact same length, you would notice that the line that I need to do to finish my triangle has to be the same. Now, of course, it's not perfect because it's on an iPad, but as soon as I have one angle and two sides that are the same with the angle in the middle, there's just really no other answer. I have to use the same length of line to close up my triangle, so to speak. I also want to point out that for side, angle, side to work, you need to have, like we have over here, a side with an angle in between the two sides that are congruent, okay? Because if you just happen to have, let's say we have a triangle, let's make it like this, and here we have matching sides and an angle, and then we drew ourselves another triangle, but the angle is not actually in between those two sides, you could keep the same angle but not have a congruent triangle, okay? Because these sides don't necessarily match over here. So that angle has to be in between the two sides. All right, there's one more way to determine if you have two congruent triangles or not, and that's angle, side, angle. So again, these triangles are slightly shifted from each other, but we can see a matching angle here and a matching angle, matching angle, matching angle, with that side in between. So just like before, you have to have that side be in the middle of our two congruent angles. So again, go ahead and try it on your notebook. Let's pretend that you're drawing a triangle and you've determined your two different types of angles. So here's one angle, and then you had your other angle here, and you drew one that was exactly the same with the same angle. Again, if you were to use a ruler and do it perfectly, if your line were to continue in a straight line from those original angles, again, if you're using a ruler, your final angle would also have to be the same because they're eventually going to cross in the same spot. So those are the three different ways to determine if a triangle is congruent. So now let's take some of that knowledge and apply it to solving some angle problems. So here we have congruent triangles, but you'll notice that they're actually put together. So the first thing that I'm going to do is I'm going to make sure that they actually are congruent or exactly the same. So I think I'm going to do that by looking for side, side, side. So I notice that I have 3.4 and 3.4 that are the same. Then I have 4.7 and 4.7 that are the same. So I have two of my sides. But if I think about it carefully, I actually know that all three of my sides are the same because this middle line matches up with each other. So I know that those ones are also the same. So based on side, 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 I can determine that yes, this is a congruent triangle. Now I can use that information to figure out what x is. I want to know what angle x is. So I know what some of my sides are, but I'm going to look at the angles that I actually already know. So the first thing I notice is that angle 101 would be, angle A is 101. Angle D would also be 101 degrees. Now, I know that a little bit by logic, just by looking at it, and I can see that it's the same distance apart. But the other thing I can notice is that angle A is directly in between 3.4 and 4.7. So then I can also notice that angle D is right between 3.4 and 4.7, but just flipped. So that might be helpful to me, but it might also not be helpful to me. But it's always good to just write down exactly what you know. Now I'm going to look over here at 32 degrees and think about how that can help me. Well, I notice a couple things. I notice that 32 degrees is right in between my 4.7 and my really long pink line that they both share. So the angle 32 degrees is between 4.7 and my pink line. So I've sort of figured that out for this first triangle here. Let me just do that in orange. Okay, so 32 degrees is between 4.7 and my pink line. So I'm going to go over to my other triangle that's white and look for the angle that's between 4.7 and the big line. And what do you know? It just so happens to be x. So I know that x actually equals 32 degrees because I'm working with congruent triangles. They're exactly the same. Now notice that x is on the opposite side of 32 degrees. So when you're working with congruent triangles, don't just assume the congruent angle is right beside the one that you see. You have to think about it logically. Now notice that angle 101, I didn't end up using it, but it was still good that I was able to figure that out. All right, let's do another one. Okay, so this is one where we are told these figures are congruent. So we're already told it's congruent, so I don't need to determine that. I'm just going to use that piece of information to solve what is the measure of angle R, or how many degrees is angle R. So I'm going to take a look around and label what I know. So the first thing I know is I've noticed that RQ and XW are the longest lines in my triangle. So it's very easy for me to just sort of eyeball it and see that this would be 61 yards. Then I noticed directly across from that long line is we have a right angle. So directly across from the long line over here, I also have a right angle. So I'm going to just put it in there. So now I have 90 degrees and 56 degrees. So if I want, I can do what we were practicing the other day, where I add up the angles that I already have sort of used up here in my triangle, and I get 146 degrees. And then I can do 180, take away 146, and I will get 34 degrees. So that's one way to do it, grade 7. But the other way to do it, and notice it matches over here, 34 degrees. The other way to do it is to kind of look at other pieces of information that I have. I could picture flipping this entire triangle and rotating it, and I would notice that my 56 degrees would end up on top of Q, and I already know that angle Q is 56 and W is 56, so then I would know that R and X equal each other. So again, I made it a little bit more complicated for myself, but I just wanted to show you my different trains of thought when I approach solving these problems. Could have made it a lot easier just by rotating it and knowing where the 90-degree angle was, but I also can do other different pieces of problem solving to arrive at the same answer. All right, let's do one more. So once again, I want to determine if I have congruent triangles. So I'm going to look first. So I'm going to look for side as an option. I don't know enough about the sides. I only know that one side is congruent, so that's not helpful. Angle side also won't help because I only know one side. So I'm going to look, do I have angle, side, angle? Again, if I take a look, yellow, I have a 90-degree angle, a side, and then an angle. a 90-degree angle, a side, and then an angle. So that means that yes, in fact, these two triangles are congruent. So now I can do a couple different things. First of all, I should be able to automatically look at angle M over here on this side and know that it is 40 degrees. The reason I know that is because I am thinking about vertical or opposite angles. Remember, when you have two lines that cross each other, they make opposite or vertical angles that are congruent. So 40 degrees goes right in here. I can then use that information if I wanted to solve for angle Q, because I have 90 degrees plus 40 degrees is 130, and then I would do 180, take away, what did I say? 130, and I would get 50 degrees. Okay, so all of these problems are slightly different, but they're all working with the fact that we have congruent triangles. Couple tips for your homework. For number 10 on your homework, I want you to really think about our rules with parallel lines and transversals, or think about vertical and opposite angles like we just talked about. That's my clue for that one. So you might think to yourself, Miss Nye, I don't have enough information to know if it's congruent. You do if you think especially about vertical and opposite angles. Okay? Make sure you work carefully. Think of it as a little bit like problem solving. The answer might not jump out to you instantly, but if you sit down, think about it, try a couple things, it should work out for you. I hope you have